Welcome, learners. Welcome to Black Slides Online Secondary School. My name once again is Mr. Pochilola, your teacher on this platform. If you are new to the platform, consider subscribing to the channel so that every time we upload a new video lesson, you are the first to be notified. Welcome, learners. My name is Mr. Pochilola once again. Revise with us. We continue with revision sessions. Remember that our revision sessions are going to run up to the end of this month, the month of June. In other words, we'll take you up to the exam season. Exams are starting in 9 days time, not 10, should be 10 days time. You're starting exams on 29th of June. Here at Black Slides, we wish you the best. Remember, it has always been, and it still is, our intention to have as many of you as possible to pass with distinctions. To pass with distinctions in the sciences. The sciences such as physics, chemistry, biology, mathematics, and agriculture. These are the sciences that we offer on this platform, Black Slides Online Secondary School. It pleases us here at the Black Slides to revise with you a post-mock chemistry paper 1 from St. Mary's. This is post-mock paper. Post-mock means a paper, an exam that is written after the first mock. So this is like second mock or third mock or thereabout. Welcome, learners. So this is another paper from St. Mary's. After we successfully revised the biology paper from the same school, we have the privilege this time around to revise with you a chemistry paper. This is chemistry paper 1, post-mock exam. Subscribe to our channel so that every time we upload a new video lesson, you become the first one to be notified. Without wasting your precious time, let's get down to the business of this day, which is to revise the post-mock chemistry paper 1. Welcome, learners. Question number 1. Figure 1 shows graph curves during the heating process to identify pure ethanol. So we have a graph curve labeled A and another graph curve labeled B. The question is, which graph represents the heating process of impure ethanol? So one of these represents pure ethanol, the other represents impure ethanol. Impure means not pure, or the ethanol containing impurities. So which graph, A or B, represents the heating process of impure ethanol? All right, so for A, you'll appreciate that the ethanol boils at 78 degrees Celsius, but for B, it is not clear at what temperature the ethanol boils. Remember that a pure substance has a fixed and constant boiling point. So in A, this must be a graph curve for a pure ethanol sample because its boiling point is exactly referred to. In this case, where the graph line is horizontal, it shows that the boiling point is constant and it is 78 degrees Celsius. But this curve just continues like that without specifically telling us where the sample boils. When the sample boils, its temperature remains constant for some time. So in this case, the temperature remains constant for sample A, remains constant for at 78 degrees Celsius. But for this curve here, there is no such a distinct point. So which graph represents the heating process of impure sample? So in this case, it is graph B. So graph B. Graph B is a perfect choice for us to represent the heating process of impure ethanol. Graph B. There's a follow-up question that requires us to give a reason. Give a reason for the answer in A. So the reason why we think it is graph B that represents the heating process of impure ethanol is that impure ethanol is a mixture. In the first place, yes, it's a mixture of ethanol and something else. So it does not have a fixed boiling point. It doesn't have a portion like this one here shown in A. So its temperature keeps rising continuously as it is being heated with no constant temperature stage. So there's no constant temperature stage on this graph, which makes our choice of graph B a perfect one. State any one variable that was kept constant during this investigation. Remember, we have two samples of ethanol. We have a pure one and an impure one. So for us to investigate the effect of impurities on boiling point of ethanol, we need to keep certain variables constant. So in this case, the variables that will be kept constant include the rate of heating or the heat supplied per minute must be the same, so that our focus is on the effect of impurities. The volume or mass of the ethanol used must be the same. And the apparatus used for heating must also be the same. In this case, if we are using a Bunsen burner, it must be a Bunsen burner for both samples. The containers being used must be the same. It must be done in the same surroundings or conditions, the same atmospheric pressure. So these are the variables that need to be kept the same. The only variables that we change are the purity, one pure ethanol being compared with an impure one. But all other variables need to be kept constant. Welcome, this is Black Slides Online, Secondary School, your place. Number 1B, Mention any two advantages of the water cycle. Recall that the water cycle is the natural circulation of water between the atmosphere and the earth. So, the water cycle has a number of significances or advantages. The question is asking us to mention any two advantages of the water cycle. One of the advantages of the water cycle is that it replenishes and renews freshwater resources such as rivers, lakes, and groundwater. To replenish means to replace the one that has been evaporated. So the water cycle gives back, it renews the freshwater resources such as rivers, lakes, and groundwater, making water available for plants, animals, and us humans to use. That's one advantage of the water cycle. It ensures a constant supply of water. It also helps to regulate the Earth's temperature and climate by moving heat energy from one place to another. In other words, the water cycle ensures that our climate is suitable for living in. Remember that water has a cooling effect. So when it gets hot, the water supplied by the water cycle is going to cool our environment, leaving it habitable. Suggest any two examples of biodegradable wastes. Recall that biodegradable wastes are wastes that can be decomposed by the action of microorganisms, such as bacteria and fungus. So examples of such wastes that can be broken down by the action of bacteria and fungus, or microorganisms in short, include but not limited to vegetable peels, fruit remains, paper, dry leaves, and animal droppings. There are many you can give, but the question is just asking us for any two. So don't mention all of them or too many, more than two. You will not gain extra marks for doing that. Give one example of greenhouse gases. Recall that greenhouse gases are the gases that are responsible for global warming or the rising of the temperature of the earth. So these gases include carbon dioxide, methane gas, water vapor, and nitrous oxides. So just any one for 1 mark. Welcome learners. This is Black Slides Online Secondary School. We are revising a post-mock paper from St. Mary's, one of the best schools in the country, girls' schools. Question number 2, figure below shows a method for testing the presence of anions. Remember, anions are negatively charged ions or negative charge carriers. They are available in solutions. So let's look at the diagram. We have sodium carbonate placed in dilute hydrochloric acid. When the two react, they produce a gas, which is delivered all through the tube up to this test tube here, which contains lime water. So name the gas labeled X. So the gas labeled X is formed as a result of the chemical reaction between sodium carbonate and the hydrochloric acid. So when a carbonate reacts with an acid, the gas formed is carbon dioxide. So all you have to do is, or to say here is carbon dioxide. Write a balanced chemical equation for the reaction in the test tube. Test tube A. Sodium carbonate reacts with hydrochloric acid. Remember that sodium carbonate is a base and the HCl is an acid, so this is some kind of neutralization reaction. When a carbonate reacts with an acid, it will form a salt, water, and carbon dioxide. So the reaction therefore would be like this. Sodium carbonate is Na2CO3 reacting with HCl, reacts with HCl to give sodium chloride, water, and carbon dioxide. Sodium chloride, water, and carbon dioxide. So this is a balanced equation. You can check the different atoms on either side of the chemical equation. Name the anions being tested in the investigation above. So the anion being tested here, the negatively charged ions that are being tested in this investigation are the carbonate ions, CO32 minus. Give any three ways of preventing rusting. Rusting is basically the reaction of iron or steel with oxygen or water. And in most cases, it's not favorable process. So it has to be prevented by all means. So what are the three ways of preventing rusting? Three ways, 3 marks. One way to prevent rusting is simply to paint iron. Painting involves coating iron or steel surfaces with paint to block air and moisture. In so doing, you prevent the iron from reacting with either oxygen or water. Painting. Rusting can also be prevented by oiling or greasing. This is done by applying oil or grease, especially on moving parts, to form a protective layer. So in order to prevent rusting of moving parts of a machine, for example, simply apply oil because oxygen does not penetrate oil. Another way is galvanization. Remember, galvanization is simply coating iron, strictly iron, with a layer of zinc and nothing else. This acts as a barrier and also protects the iron sacrificially. May I urge you to go back to look at the process of sacrificial protection in case they ask you. Explain what is involved in galvanization of iron using zinc. Figure below is a diagram showing an experiment which a student carried out in order to purify copper metal. So the setup consists of a battery. This must be a battery, not a cell. An ammeter. The cell of the battery supplies power to the circuit. The ammeter detects the flow of current. And then we have the two electrodes here, the cathode. Remember, the cathode is the electrode that is directly connected to the negative of the battery, and that connected to the positive of the battery is called anode. So the impure copper is placed here, connected to the positive of the battery. And then you have an anode, in this case, I mean a cathode, this other end. Then a beaker, and you have a solution Z. So take note here that we are purifying copper metal. When you are purifying copper metal, make sure that the solution in which you are using an electrolyte must also contain copper ions. So name the solution, name the electrolyte being used here. So the electrolyte being used is the copper sulfate solution, but you can also use the acidified copper sulfate solution. Why? The idea is to have copper ions in the solution. Write down the ionic half equations for the reactions taking place at each electrode. At the anode is where you place your impure copper metal. This is copper metal that has impurities in it. So we just want to get the copper and leave the rest of the impurities there. So the half equation at the anode here will be the oxidation of copper, which is basically dissolving of the copper metal, the impure copper, into the solution. All right. So the copper ions in the solution are going to gain electrons from the external circuit. The electrons, and this will reduce the copper ions to copper metal, which is needed. And that copper metal is going to coat on the cathode. You should be able to observe copper metal being coated there. So we are saying the ions in the solution are going to gain electrons to form copper metal atoms, which will be coated on the cathode there. That's reduction. So how do one tell that indeed copper has been purified? There are a number of observations that you'd look for. One of the evidence of purification of copper is that the cathode is going to gain mass. It becomes thicker as pure copper metal is deposited on it here. The anode, on the other hand, will lose mass to become thinner, and a slimy insoluble residue, which is called anode sludge, settles at the bottom of the beaker. So this contains impurities like silver, gold, and other things. Welcome, learners. Give any two necessary conditions for rusting to take place. I mentioned rusting earlier on. Rusting is when a metal such as iron reacts with oxygen or water. It forms an oxide, which in most cases is undesirable. So for this to happen, for rusting to happen, there are basically two conditions, or three. One of the conditions is the presence of oxygen. So when the iron is exposed to oxygen or simply air, it is going to react with the oxygen in rusting, which is an oxidation process, but also the presence of water or moisture would bring about rusting in the iron. Making matters worse would be the presence of sodium chloride, which is salt. This speeds up rusting process. So the oxygen and water are essential requirements, but when there is salt also in the solution, in the water, the process of rusting is going to be speeded up. Figure 4 shows structures of allotropes of carbon. Use it to answer the questions that follow. So we have the two allotropes, X and Y. Which of the structures of carbon conducts electricity? It's required that you should identify the allotropes. This happens to be diamond. This happens to be graphite. So between diamond and graphite, it is graphite that conducts electricity. So in this case, it's structure Y. Also required in 3 marks, required to describe the answer. Why are we saying structure Y? It's simply because of the bonding in graphite. Structure Y, which is graphite, consists of carbon atoms arranged in flat hexagonal layers. These layers that are stacked loosely but on top of each other. So what happens here is that each carbon atom is bonded to 3 others. Each carbon atom is bonded to 3 others. Is bonded to 3 others, leaving 1 free electron per atom. So it is those free electrons, that are able to move freely throughout the layers, thereby carrying electric charge, which allows graphite to conduct electricity. 3 points, 3 marks. Mention 2 uses of structure Y. In other words, the examiner is asking you to give 2 uses of graphite. Graphite is used in a number of applications. It's used to make electrodes, as we've seen in batteries. In the very middle of cells, dry cells especially, there is a rod there made from carbon. We also use this in electrolysis or electrolytic cells. We also use graphite for making pencil reeds. The one you use for drawing is a mixture of graphite and clay. Graphite is also used as a lubricant in making crucibles for high temperature work. So just pick any 2 for 2 marks. Don't write all of them. After all, the question is just 2 marks. This is Black Slides Online Secondary School. Welcome, learners. My name is Mr. Pochilora. Remember, we are revising a post-mock paper from St. Mary's, one of the best girls' schools in the country. State 2 similarities between silica and diamond. Remember, silica is a traditional name for a chemical called silicon dioxide. Silicon dioxide is a substance that is found in sand. Remember, sand is a very hard substance. It is because of silicon dioxide or silica that's in it. So there are similarities between silicon dioxide and the diamond. The examiner is asking you for 2 of them, for 2 marks. One of them is that both have a giant covariant structure. Look at the 2 structures in your textbooks. They are both made of a network of atoms bonded together by strong covalent bonds. They are both giant covalent structures. Both of them have very high melting and boiling points, owing to their strong covalent bonds between the atoms. So this will require large amounts of heat energy to break such strong bonds. And both of them are hard solids. Imagine sand and diamond. They are very hard materials. So both are hard substances. They both do not conduct electricity, and they both are insoluble in water. Here we've combined a number of similarities. But you are simply required to state two. Define the term conformer. In chemistry, when you're looking at isomers and conformers or conformational isomers, we define the term conformer as simply any of the different spatial arrangements of atoms in a molecule, especially in an organic compound, that results from rotation around a single carbon bond. Just twist the bond, it will give you a structure that seems to be different from the other, but actually not. So these forms are not different compounds, just different shapes. The same molecule can take, and they easily interconvert, meaning they change from one structure to another physically by simply twisting at one bond. That's the definition of conformers or conformational isomers. They're not necessarily isomers, they're just conformational isomers. Below are organic compounds of different homologous series. Homologous series are families of organic compounds. We are required to use these to answer the questions that follow. So very quickly we have structure P, Q, R, and S. To which homologous series, to which family of organic compounds does the organic compound Q, this one here, belong? All right, for us to classify an organic compound, we have to look at the functional group. This contains an OH group, which is called a hydroxyl group. Anything that contains a hydroxyl group is an alcohol. Remember, alcohols are also called alkanols. So organic compound Q is an alkanol or alcohol. Alkanols, as they're also called alcohols, like ethanol is an alcohol, is an alkanol. Name the organic compound R. Here we have to be a little bit systematic in our naming, because there's an OH there and there's also a branch there. And the parent chain has 5 carbon atoms. So we can number the carbon chain as 1, 2, 3, 4, and 5. So when naming this, priority goes to the OH, which is the functional group, and less priority is given to the branch. What I mean by this is that the lowest number must be on the branch where the functional group is, and not where the methyl group is placed. So the name of this organic compound is a 4-methyl pentane 2-O. Take note that we have numbered from the right 1, 2, 3, 4, 5. So the methyl group, the branch, is on carbon number 4, but the functional group is on carbon number 2. So priority goes to the branch containing the OH, the functional group. Draw two possible structural conformers of compound P. Mind you, we are not being asked for isomers, but conformers. Remember, conformers are just the same structure twisted in different directions. So what we are going to do is just to twist these carbon atoms, bend that way, or bend it this way, like that, without creating any more branches apart from this one here. So the two possible structures can be this one here, the one that's given there. Mind you, this has 4 carbon atoms, 1, 2, 3, 4, as the first one. The other one can be this one. We just bend this one down, this carbon down. It's the same as this one. Remember that conformers are not isomers. They are not different structures, just the same structure. We are just bending one end. So we have bent this one. One may think that these are different structures, but actually not. Another structure, which is basically the same as the first one, is this one. You bend this carbon atom here, it will come there, like here. The original one was this side, so you bend this one here, and also bend this one this side. Bend, it's going to look like this, like a chair. These are called conformers, structure conformers, not isomers. Two marks. Given two chemical properties of organic compound S, first of all, let's identify S. S is a carboxylic acid. Why? How do we know that? This is a carboxyl group, right? It's an arachidonic acid. So like all other acids, they will undergo chemical reactions with bases or alkalis. So we are saying S, which is carboxylic acid or arachidonic acid, is going to react with base to form salt and water. That's one. That's called neutralization reaction. Can also react with carbonates, such as hydrogen carbonates, to produce carbon dioxide gas and salt and water. You can add another one if need be. Carboxylic acids can also react with metals to produce to produce hydrogen and salt. These are the two chemical properties of a carboxylic acid. Number 6. What is the difference between a polar covalent bond and a non-polar covalent bond? A polar covalent bond and a non-polar covalent bond. The differences between them, 2 marks. So a polar covalent bond is formed between atoms with different electronegativities. Remember, electronegativities is the electron pulling power of an atom. So a more electronegative atom is going to pull electrons from a less electronegative atom. The result is a polar covalent bond. Example, in hydrogen chloride, HCl, chlorine is highly electronegative. It's going to pull electrons from the hydrogen, which is less electronegative. This creates partial charges, a partial negative charge and a partial positive charge. While nonpolar bonds form between atoms with similar electronegativities with equal sharing and no charges. Examples include the diatomic molecules such as chlorine, Cl2. Since the atoms have equal electronegativities, it means they have equal pulling powers. Therefore, they are going to be nonpolar. In other words, there will be no partial charges formed on such molecules. Another one is nitrogen molecule, N2. The two nitrogen atoms in a nitrogen molecule, the two atoms will have equal pulling power because both have equal electronegativities. So there will be no partial charges formed on such molecules. Take note. State any one example of a compound with a coordinate bond. Remember, coordinate bond is also called dative bond. So examples include the ammonium, hydronium ion, and carbon monoxide. Make sure you know these examples. All right, in the future, you'll be asked to explain how these become or form coordinate bonds. Mention any one use of metals in relation to their properties. Copper used for electrical wiring. Copper is used for electrical wiring. Why? It's because it is a good conductor of electricity. The reason why we use copper for electric wiring is because copper is a good conductor of electricity. It has free electrons, but it can also be drawn into wires. We call that ductile. We call that ductile. Hey, girls, can you proceed to where you're going? Leave that place, you're making noise. I've said it once. Next time I'm coming out. Fine. So copper is used for wiring, electric wiring. The reason is because it is a good conductor of electricity and it can also be drawn into wires. We call that ductility. It's ductile. Mention any one use of metals in relation to their properties. So the property here is the fact that it conducts electricity and is ductile. That's why it's used for making electrical wires. Aluminium is used for cooking pots. Why we use aluminium for cooking pots is because it is a good conductor of heat and it has a high melting point. A metal used for cooking should not melt easily, otherwise that would be dangerous to use. So aluminium is a good conductor of heat and has high melting point. That's why we use it for cooking pots. Iron is used in construction work simply because it is strong and hard. Materials used in construction work should not be weak materials, should not be soft materials. They should be hard enough to withstand forces or weights, to hold the weights of different other parts of the buildings. Welcome, learners. My name is Mr. Paul Chilola, your teacher. Question number 7. Define the term polymerization. This is organic chemistry. We define polymerization as simply a reaction, a chemical reaction in which monomers are smaller molecules, small single molecules, join to form polymers with or without elimination of smaller molecules. This is different. With sometimes polymerization can produce smaller molecules such as water or hydrochloric hydrogen chloride. And recall also that there are two types of polymerization, namely addition and condensation. Welcome, learners. Figure shows the polymer, this one. Name the polymer. We are going to be guided by the presence of this chlorine atom here bonded. This means that the polymer must have come from a vinyl chloride molecule. So the long chain of this polymer is called polychloroethene, or you can call it polyvinyl chloride, in short PVC. It's allowed for you to say PVC. Draw a structure equation to show the formation of PVC. So the equation involves simply a molecule of vinyl chloride. This one is vinyl chloride. It's basically an alkene where one of the hydrogen atoms is replaced by a chlorine atom there. That's called the vinyl chloride. It's a monomer. So this N here represents many of these. It can be 10, 20, 100, even thousands, millions of these are going to combine under these conditions: high temperature, pressure, and the use of catalyst. An example of a catalyst used for this intention is benzyl peroxide. Benzyl peroxide. So the product is going to be a PVC. Instead of drawing a long chain, you just draw out part of it consisting of two carbon atoms and a single bond. Make sure there's no double bond here. It is split. And then include this or place these in the squared brackets and put the N just at the bottom there. This N represents the number of these units which are joined together to make a long chain. Welcome, learners. My name is Mr. Pochilola, representing Black Slides Online Secondary School. describe how this polymer PVC was formed. 4 marks. So PVC is made by a type of reaction called the addition polymerization from the monomer chloroethene, which is also called vinyl. This is called vinyl. A single molecule is called a vinyl molecule. It's a monomer. So the reaction occurs under high temperature, high pressure, with a catalyst such as benzyl peroxide. Benzyl peroxide is the catalyst to speed up the reaction, this reaction. The splitting of this bond and the joining of the same molecules a number of times to produce PVC. You need the conditions, temperature, high pressure, and the use of a catalyst. An example, in case they ask you for the name of the catalyst, is benzyl peroxide. So the carbon-carbon double bond will break, and the monomers are going to link end to end to form long chains, which is called addition polymerization. All right? So in the process, in addition polymerization, there are no smaller molecules that are eliminated during the process. Unlike condensation polymerization is accompanied by the elimination of smaller molecules, which can be water or hydrogen chloride. Just to revise this topic fully to see the difference between addition polymerization and condensation polymerization. Welcome, learners. Question number 8. Figure 6 shows different surface areas of calcium carbonate which were used to react with dilute hydrochloric acid separately in an investigation conducted by Form 4 students. Time taken for each reaction was recorded. So just a quick look. We have calcium carbonate, a large particle, and then in one experiment and in another experiment, it's broken down into even smaller particles, and then in a separate experiment, these are split further to form finely divided particles of calcium carbonate. By the way, this is supposed to be CaCO3. This 3 here is not, it's eliminated for some reason, but it's supposed to be CaCO3. What was the aim of the investigation? What was the aim of the investigation? Or not of the investigated, but of the investigation. The aim of this experiment was to investigate the effect of surface area as the calcium carbonate is being divided up or split into particles. The surface area is changing. As a matter of fact, the surface area of contact between the calcium carbonate and the acid, hydrochloric acid, is increasing. So the aim is to investigate the effect of surface area or particle size on the rate of chemical reaction. Which calcium carbonate will react slowly with dilute hydrochloric acid? So the one which has a large lump will have smaller surface area, therefore it's going to react slowly. So in this case, calcium carbonate in the large lump, this one, will react slowly because it has smaller surface area in contact with the hydrochloric acid. Explain your answer in 8B. Explain your answer. The explanation must have to do with surface area. Right, so it has the smallest total surface area exposed to the acid. So as a result, there's going to be fewer solid particles which are in contact with the acid particles at the same time, fewer. So the reaction will be slow. So we are saying there are fewer effective collisions per second, so the reaction rate is going to be slow. Welcome, learners. State any one factor that must be kept constant in the investigation. While our focus is on the effect of surface area, we need to keep certain factors constant. Among them, we need to keep concentration the same, concentration of the acid, or the volume of the acid used must also be the same. Temperature must be kept constant, and mass, we must use the mass, the same mass of the samples. And here you can appreciate that same masses were used, 10 grams of each sample. That means mass was kept constant. Welcome, learners. My name is Mr. Pochilola, your teacher. Join us on Black Slides. Subscribe to the channel. Remember, we are revising a post-mock paper from St. Mary's. This is Chemistry, Paper 1. Welcome, learners. Figure 7, number 9. Figure 7 shows energy level diagram for the reaction of sodium hydroxide and hydrochloric acid. So sodium hydroxide reacts with hydrochloric acid to produce sodium chloride, which is a salt, and water. This is a neutralization reaction. So in the first place, when these are mixed, they'll split into their ions and then recombine to produce the final products, to give the final products. So state whether the reaction is exothermic or endothermic. If you look at the products here on the profile, the products are at lower position here, lower level than the reactants, which means that the products have less energy or lower energy than the reactants. And therefore, it must be exothermic. In an exothermic reaction, the products have lower energy than the reactants. So this is exothermic. Take note that the products are at lower level here, while the reactants are at a higher level. So the reactants have more energy than the products. Give a reason for your answer to question number 9B. 1. This is question number 9, Roman numeral 1. Why are we saying it's exothermic? It's because the energy of the products, which is sodium chloride and water, is lower than the energy of the reactants. How do we know it's lower? The level here is lower than this one. That's why we are sure this must be exothermic reaction. That means they have less energy than, the products have less energy than the reactants. So this means the energy is released to the surroundings during the reaction, which is the characteristic of an exothermic reaction. But also this must be negative, confirming that energy is given out. Welcome, learners. My name is Mr. Pochilola, your teacher. Question number 10. Define the term conjugate base. This is in reference to chemical reactions called the acid-base reactions. Define conjugate base. We define a conjugate base as a species or a product formed when an acid donates or loses a hydrogen ion, which is a proton. Remember that acids are proton donors. They donate hydrogen ions. So what remains of it is called the conjugate base, which has the potential also to gain a proton to form back the acid which made it. Hydrogen carbonate, H2S, this is not hydrogen carbonate, by the way. This must be carbonic acid. Carbonic acid reacts with potassium hydroxide as shown. As shown by the conjugate acid-base pairs. So these are conjugate acid-base pairs. This is an acid and that is conjugate base. This is acting here as a base and this is conjugate acid. Write a chemical equation for the reaction. So here in the reaction, the acid, which is carbonic acid, is reacting with water to form potassium carbonate and potassium hydroxide. So the reaction is going to look like this. Carbonic acid reacts with potassium hydroxide. To form a salt, potassium carbonate, and the water. Please take note. From the equation written in, identify the conjugate acid. So the conjugate acid is what remains of a base, or what it is formed. Conjugate acid is what remains of a base when it gains a hydrogen. So in this case, the OH here gains a hydrogen from the carbonic acid to form water. So in this case, our conjugate acid is water. While a conjugate base is what remains of an acid when it donates a proton. So here, the carbonic acid donates its proton to potassium hydroxide to form this. Therefore, the conjugate base is going to be the potassium carbonate. So take note. So we are saying the water is our conjugate acid, while the potassium carbonate is our conjugate base. So the conjugate base in this case could be carbonate ion, or simply this structure is potassium carbonate. Here we go. I'm coming. Study the flow chart below and answer the questions that follow. So This is the schematic diagram of a process. It's called a flow chart. A flow chart shows stages of a process. So hydrogen is combined with a certain substance D to produce ammonia. And the ammonia undergoes further reaction with substance E to form ammonium phosphate. Name the following substances. D must be nitrogen. Because how do we know that? The ammonia there is produced when hydrogen reacts with nitrogen. So D must be nitrogen gas. And E, the substance that reacts with ammonia, must be a phosphate or phosphoric acid. So this is a base reacting with an acid. So this is concentrated phosphoric acid. This is production of fertilizer called ammonium fertilizer or ammonium phosphate. Give any two optimum conditions, the best conditions necessary for this reaction to happen. This is Haber process. The production of ammonia is called Haber. So Haber will take place under the following optimum conditions. The temperature must be between 450 degrees and 500 degrees. The pressure range must be 200 to 250 atmospheres, which is quite high pressure, to ensure that as much ammonia as possible is produced. But there must also be the use of catalyst to speed up the process, the combination of nitrogen and hydrogen. A good example is aluminum oxide or potassium oxide. These act as promoters of the process. Welcome, learners. Question number 11. With the aid of chemical equations, describe how hydronium ion H3O plus can be formed. Remember, this is a coordinate compound or a compound displaying coordinate bond or dative bond. So for this to be formed, acids such as hydrochloric acid will dissociate in water to produce hydrogen ions. That's the first thing that needs to happen. So the HCl is going to split into hydrogen ions and something else. Once that happens, since the ions are highly reactive and do not exist freely in the solution, they are going to bond immediately with water. So water will gain these high ions from the acid using the lone electron pair on oxygen. So in the end, you are going to have hydronium ion being formed. So the overall equation is going to have HCl reacting with water to give hydronium ion and a chloride ion. So this is what you have to describe in 5 marks. Welcome. Describe how deforestation may lead to water hardness. Remember that water hardness is a situation whereby there are dissolved salts of calcium and magnesium in it. So how does cutting down trees lead to water hardness? So loss of trees removes root systems that bind soil together. You know that? when trees are lost, like you cut trees and necessarily the roots that bind soil together are going to be removed. And as a result, rainwater would easily wash away the exposed soil by a process called soil erosion. So the runoff is going to dissolve calcium and magnesium minerals from the rocks and soils. These are going to be dissolved, rather they're going to flow into rivers, lakes, and groundwater. By the end of the day, the high levels of these salts, ions, will make the water hard, or the water will contain ions of calcium and magnesium in it. This is how deforestation links to water hardness. Welcome, learners. With the aid of a well-labeled diagram, describe how sulfur can be extracted from underground. I don't know, you candidates, if you realize that this has to do with the fresh process. So in other words, the question is asking you to describe the fresh process. So first of all, you have to draw a diagram like this with three concentric pipes. One delivering superheated water and another delivering hot compressed air. These are concentric pipes, pipes that can fit into each other. The large pipe, outer one, then you have another one which is a bit smaller, and then the smallest pipe in the middle. Make sure you know this diagram very well. I took it from Excel and Succeed, book 3, chemistry. So the sulfur is found down here. So pipes are dug into the ground up to where the sulfur is found. So by drawing this diagram correctly to max, the description involves saying that 3 concentric pipes each reach the underground sulfur bed. So these pipes are sunk into the sulfur bed, and then superheated water is pumped. Superheated water is pumped down the outer pipe to melt the sulfur. Take note that the temperature of the water is about 107 to 160 or thereabout, but much higher than the melting point of sulfur here. So when the water reaches the bottom here where there is sulfur, it's going to melt it. Then the compressed air is sent down again, down the inner pipe to form a light frothy mixture, that is like porridge-like mixture. Then pressure pushes the mixture up the middle pipe to the surface. Follow the direction of the arrows, like that. So this is molten sulfur, goes out like that, is collected there. So the water and the air are removed, leaving pure solid sulfur. And then it's taken to the storage tanks. Welcome, learners. So this must give you 10 marks. Many candidates could not have told that this is basically the fresh process. The fresh process. Describe how to prepare lead sulfate crystals using lead nitrate and magnesium sulfate. So the process involves dissolving lead nitrate and magnesium sulfate separately in distilled water to form two clear solutions. So dissolve the two to form solutions. Then you mix the two solutions together. This is formation of salt. A white precipitate of solid lead sulfate forms immediately. This is precipitation. Then the mixture is filtered to separate the insoluble lead sulfate solid from the solution. Once that is done, you wash the solid residue on the filter paper with distilled water in order to remove the soluble impurities. And then lastly, you dry the washed solid to obtain pure lead sulfate crystals, because the question is asking for crystals. Welcome learners. We are revising the post-mock paper from St. Mary's, one of the few best schools, girls' schools in the country. Welcome to the last question. Describe how you can make a 250 mils of a 0.2 molar copper sulfate solution from copper sulfate crystals. This is making a solution by dissolving solids. So the target is to form 250 mils of 0.2 molar copper sulfate. So first and foremost, you calculate the molar mass of copper sulfate. The molar mass of copper sulfate is 159.3 grams per mole, from which you find the number of moles needed. Remember, number of moles is equal to concentration multiplied by volume. So the volume, this one here, is changed to cubic decimeters. Just divide the 250 by 1000. You have this. You multiply this out, you get the number of moles, which is 0.05 moles. Then calculate the mass required. Remember, mass required is equal to number of moles multiplied by the molar mass. So in this case, the mass of the copper sulfate, which we need, is 7.97 grams. So using a balance, you would measure this. So weigh exactly 7.97 grams of copper sulfate crystals using a balance. A good balance which can measure up to the accuracy of 0.97. Welcome learners. So once this is completed, transfer the crystals into a clean 250 cubic centimeters beaker and dissolve. So add about 100 cubic centimeters of distilled water and stir the mixtures.
paper of what? The concept note. Then there are you write that one as a limitation. Okay, they will if we wait. We can employ another teacher.
Hey.
That's what he's saying. And people are saying no traditional maths. What's the prince away? Don't think glucose of incentive. Come on, Raja.